Hi, everyone. My name is Chevon McKay. I'm a biomedical engineering technologist in Halifax, Nova Scotia, Canada. I've been in the biomedical field for about 6 years now. This webinar is going to be mostly on the safety and maintenance of an ophthalmology laser. Today's August 30th, 2022, and hopefully this gives some good insight and information for anybody that works with ophthalmology lasers. We're mostly going to be going over the 532 nanometer laser and the safety and maintenance of some of those, especially the ones that I'm used to working on. So the topics today is going to be, the first one is going to be safety. So what types of controls are used for safety wise? Examples of hazards. So what could happen in the clinic or operating room that could be a hazard to you and or your patient. Also going over some PPE that's needed for doing laser procedures, such as glasses, window frames, and any signage. Next would be maintenance. So this is more of the biomedical side of it. We'll look at some electrical safety, what's reasonable and what tolerance it needs to be in. We'll also look at the maintenance of an Alcon constellation, the 532 nanometer laser, as well as a Carl Zeiss Visualis Trion. That one's a multi-wave laser. So 532, 561, and a 659 nanometer. We'll go over some of the maintenance and safety involved with using a multi-wave laser that has 3 different wavelengths. Next, we'll go over some troubleshooting. This could be for any biomed, nurse, doctor, anybody that's going to be in the laser room. So aiming beam and the treatment beam, how they align and what needs to be done to make sure they're in sync with each other, as well as light and power. So any bulb issues, any power issues, things like that, that you can look over in order to save time possibly on troubleshooting and what may be wrong with the instrument. So types of controls, we have elimination, substitution, engineering, administration, and PPE, personal protective equipment. So for those, we'll go over what ones we can and cannot use just based on the situation when we have a laser in the room. So for elimination, we cannot physically remove the control, which is the laser. So we needed to get the job done. So we obviously can't remove the laser because we need to do the procedure. Substitution, we cannot replace the device laser with a less hazardous one. All medical lasers are class 4. So class 4 lasers, we need to have this personal protective equipment on. We need to have it so we can do the procedure properly. So all medical lasers are class 4, which means that any laser under that wouldn't be considered a medical laser. So you wouldn't be able to do a procedure with a class 3. Technically, some do have class 3 lasers, some towers, which are used for aligning scopes, things like that. Engineering, we cannot isolate people from the situation. We need people to operate the lasers. What we can do though is remove people who are not involved with the situation or the procedure. So anybody that technically doesn't know how to use the laser or doesn't need to be in the room and doesn't have the proper PPE on or the training to be in a room, a laser personnel, they should not be involved with the situation until those courses and safety guidelines are in place. Administration. So we could change the policies and procedures and education in order to provide better hazard control. So what we can do is provide education. So on laser room personnel, for example, what needs to be done in the laser room, what precautions need to be taken while the laser is firing. We also have a laser console operator. So that is a nurse usually, how to operate the console. So how to set your power and wavelengths and all the things on the console of what the doctor wants for power-wise, and if it's pulsed or unpulsed. And then we have the laser operators. Usually it is the doctor, so they'd be trained by the manufacturer on how to use the laser properly, what the wavelength does with tissue interaction, and just basically usually it's the doctor, the person actually firing and using the laser to do the procedure. PPE. So this is the most effective balance of controls we can provide. So it protects the staff and patients from potential harm. Usually in ophthalmology, the patient isn't technically protected because you need both eyes in order to fixate on the light and when you're getting treated. But for the staff, they should be using their PPE, such as glasses or masks if needed, as well as making sure signs are up. But we'll go over that later on in the presentation. So we got some examples of hazards here. So the laser beam can be broken and be out into the room. The electrical cords, they could cause electrocution if electrical cords are broken. Fire, the laser could accidentally take a hit to paper, plastic, anything like that, cause fire, as well as any other medical equipment. Doesn't have to be a laser, so it could be a power source of some sort or another piece of equipment. Noise is a hazard. If the doctor or the laser console nurse does not know what settings it should be on, if there's a lot of noise, she might not be able to hear the doctor saying what settings he wants those on. So that could be a hazard, not knowing what settings are needed. And other devices and obstacles, such as electrical cords or other pieces of equipment in the way on the floor, as well as people in the way. Make sure the room's clear, especially with the laser beam and where it's going in the room. Make sure there's nobody obstructing that laser beam view. So here's an example of a broken fiber causing the laser beam to be exposed into the room. So here, what happened in this situation is the tip of the probe got really warm, so all the energy was going towards that part of the probe where it goes into the device. So what happens there is it's a hazard because the laser energy could be out into the room and not technically at the patient. So if you're a person that's in front of the laser beam there, where it's cut in half and the laser energy is exposed in the room, you might think that the laser power is going straight to the patient, but with that break and the laser energy coming out, it's technically going and splattering all into the room. Here's another broken fiber causing laser light to be exposed, even though it was inserted to the body. So this is more of a urology example. So where they have the laser into the body, a lot of people think that they shouldn't be wearing their laser safety glasses. In this case, the fiber was broken on the outside of the patient, so it wasn't broken where it was in the patient. So technically where that's twisted and turned, if that had broken, the laser energy would be all in the room with a hazard to everybody in the room if they didn't have their safety glasses on for an accidental hit, because it was outside the body and not into the body. Here's some more pictures of broken strain reliefs and fiber causing light to be exposed. So as you can see, they have, it shows where, especially the third picture, it's not a straight cut and more of a spiral cut there, where it would not straight diverse into a straight line of laser energy, but it would spiral into the room, meaning it could hit anywhere in the room and not a direct hit into one straight line. So again, if you don't have your laser safety glasses on, this could be an issue if laser light gets out into the room. Another hazard, this is a picture of a broken power cable on a laser. So when you're done a laser case, you should always check the power cord before, maybe after. This could cause electrical hazard, especially if you end up touching it, trying to pull the cord out of the electrical outlet, or if you're wiping it down, this could cause electrical shock. So not just the laser fibers can cause issues and hazards, it could also be your power cables that provide power to the laser. Another electrical hazard, the damaged main switch. So here, there's supposed to be a toggle on the switch to turn the laser on and off. And this is a 240 volt electrical supply. So what happened was we had to replace this whole switch, and to use anything else to toggle that, we've heard of people trying to use screwdrivers, safety pins, things like that to move the switch up and down, but it could be electrical safety hazard just based on it not being wired properly, or metal on metal into it that could cause shock. So PPE, this is kind of a chart I've done up, saying what wavelengths we have here at our facility. Just kind of gives you an idea if you have laser safety glasses on or if you don't. So if you don't and you get a hit, each of these wavelengths that are listed show if it affects the cornea or the retina. So normally in ophthalmology, the 532 treats the retina, but it can also cause damage if not properly used, or an accidental hit to the eye. So if you see on 532 shows in the red, it affects the retina. So if you get an accidental hit by a 532 laser, it's going to affect your retina, which in most cases is unrepairable. So definitely safety glasses are a big thing and should be used when in a laser room for an accidental hit to the eye. So rating of laser safety glasses must be matched up on the wavelength and OD optical density in which they provide protection. So if you look at these glasses here that I took a picture of, these glasses will cover the 532 laser with an OD of 7. So they also, if you look at the numbers in between, they also cover a range of 960 to 1064 nanometer with an OD of 7+. So if you have an OD of 5, these would not be good. So anything over 7 and anything in the range of 190 to 534 nanometers. So in our case, again, the 532 laser, if it has an OD of 7, would be covered with these glasses. So should be worn during a laser case with that wavelength. Laser surgical masks are required when plume is generated, not so much in ophthalmology, but other areas such as gynecology and urology, if it generates bioaerosols, viruses, and toxins. So masks must be 0.1 micron compared to the surgical masks that people have been wearing during COVID and your regular masks in the hospital, which are only 0.3 microns. Also, smoke evacuators, sometimes in ophthalmology, sometimes not, depending on the procedure, or suction units must be used if plumes generated. They also must be sized properly for the amount of plume that will be created. So this smoke evac is ones we use commonly here in our facility, and they're sized properly and configured to specific range of how much plume they're expecting to be generated with each procedure. So signage. Signage. So this is another part of kind of PPE, I guess, in a way, for safety of having a laser. So each sign for laser safety and for regulations must have the word danger. Some of them do have caution on them, which is fine as well. They also must say laser radiation, so what's in there. You'd see some for X-ray too, where it'll say X-ray radiation or just radiation in general. Also on the sign has to have the type of laser. So on the outside, people know what glasses they are to use. We also, for our facility, put the eyewear requirements. So you'll have your wavelength, maximum output. So how much output is the maximum for the laser? So in this case, it was the Constellation, and that gives 2.5 watts maximum. What class laser? So class 4 laser, which all of our medical lasers are. And eyewear requirements, again, it just says what the wavelength is and the OD. So with the sign, you have your glasses set up outside so people know what to put on if they need to be in the room. So like I said, in this case, the type of laser is the green laser, the Alcon Constellation. The wavelength is 532, output 5.2 milliwatts, class 4 laser, and what eyewear you should put. So this is an example if people want to adapt to our signage and what we've done here, they're more than welcome. It just gives an idea inside the room of what glasses you need to put on and what kind of scenario you're getting into with how many watts is maximum coming out, as well as your wavelength and what kind of class laser it is. So now we're going to get into the maintenance of some of our lasers. This is mostly biomedical related, so electrical safety. Most electrical safety is done every 12 months on our lasers, unless the manufacturer suggests it otherwise. Some of them are 6 months, 3 months. We have different types of equipment. It depends on the manufacturer recommendation when electrical safety and checkouts are to be done. Our standard here in Canada is ground resistance should be no more than 0.2 ohms. Enclosure leakage should be no more than 500 microamps. And if there's a patient leakage if patient leakage is applicable, should be no more than 10 microamps. So down below is some pictures of some electrical safety devices that we use and have here at our facility, which I check for electrical safety on lasers and other ophthalmology equipment. So the Alcon Constellation, the 532, for what the manufacturer recommends is every 12 months. So you want to do maintenance, electrical safety, and power verification. So for the maintenance, for this laser has an Endo Probe and LIO. So what we do for the Endo Probe, we check the distal end into the laser, which is connected to the laser and the laser meter head. What you do is set your exposure time to continuous wave. So that will give you a continuous wave to have a reading that is continuous, so you can catch it on your laser meter. There's a checklist on the next page for this as well. So if you want to go over that first, it kind of makes sense when reading through the steps here. So then we'll set the treatment power to 0.10 watts and then press the standby ready key. So this would make it ready for ready to fire. So when you fire the laser, you record the values as reading as determined from the laser meter. And then again on the next slide, you repeat all steps for each value of the table. Same thing goes for the LIO, so the headpiece. So that's an option for the Alcon Constellation. So what you do is put the distal output beam onto the laser meter head that's connected to the laser. Same thing, make sure your aiming beam is lined up onto the laser meter head, so you know that your treatment beam is hitting in the exact same spot. That's if it's calibrated properly. Again, you're going to set the exposure time to continuous wave, so you get a constant reading, so it's not fluctuating, pulsed back and forth. Set the treatment power to 0.10 watts, then press the standby ready key. So this is now ready to fire. Fire the laser and record the readings as determined from the laser meter. And then again, repeat all steps for each value of the table. So here's the table I was talking about. So you have your Endo Probe and LIO sections. You're going to be measuring 0.10 watts, 0.30 watts, and 0.70 watts. Again, on the right-hand side of that is where you're going to put your readings down, what you get off your laser meter. And on the side of that is what your range should be for your values. And if they're all within range, that means your laser is putting output properly. If not, then there's other issues going on. Could be your fiber, could be your laser in general in the machine, many different issues like that. But that's how you do a normal checkout for the Alcon constellation, making sure your power output is coming out properly. So some things to do before starting a case. Check your chassis for damage. So just look around the machine, make sure there's no cracks, no damage on the cord, power cords, the screen. Make sure your touch screen's working. Also clean your device using only approved cleaners to avoid damage. So every manual that you get with any laser or any device normally comes with what cleaning devices and what cleaning solutions should be used in order to clean and disinfect. Clean lenses on LIO using approved cleaners. So any optics that are on the LIO headpiece, make sure they're clean with approved cleaners. Normally it's a lens cleaner of some sort or methanol. Check for breaks and fibers. So when you put your fiber in, just give it a go over once, maybe to see if there's any breaks or any visible damage before the case starts. Check for breaks or tears on the power cord. Make sure everything, there's no cuts in the insulation, and check for damage to the foot switch and foot switch cables. So just kind of go over the foot switch, make sure there's no cracks, make sure there's no cracks over, there's normally a shroud over the laser foot switch, make sure that's intact, as well as the foot switch cable, make sure that's connected properly and no cracks or cuts. Next, we're going to go on to the Carl Zeiss Visualist Trion. This one does have a 532 laser in it. It also has two other wavelengths, 561 and 659. Again, we're going to go over maintenance, electrical safety, and power verification of this laser. So kind of similar to the Constellation. So checking the therapy beam. So this is what I was talking about before, where you make sure your therapy beam and your aiming beam are kind of in line, and checking make sure the wavelengths are in range on your meter. So what you're going to do is switch on the console, select slit lamp. So this one has a slit lamp again and an LIO. Select the default program, and on this one you can select your wavelength. So for in this case, we're going to do a 532. So we're going to select 532 nanometer. Activate the aiming beam and press the brightness button to set the brightness to level 3 using the jog dial. We'll see a picture as well of what the console looks like. Attach the power meter sensor to the headrest and position in a way that the aiming beam diameter is approximately 2 millimeters is obtained. So this is the red aiming beam. You want that in the center and big enough, about 2 millimeters, onto the head of your laser meter, so it is reading properly. And then set the power meter wavelength to 532 again, and then perform the laser power measurements. Again, you're going to repeat this procedure for wavelengths 561 and 659, and again for the LIO readings. So here's kind of where the console is here. You can see where it's selected to 532 green laser. We have it at a 50 millisecond pulse. You can see at the top there, and it's a single pulse. Select it. On the right corner here, where we have, it looks like the slit lamp and the mirror, that's where it shows that it's in the slit lamp position and not the LIO. And down here is your ready and standby button. And here is where you set your power. So you can click on that and adjust it with the dial over here. So right now it's at 50 milliwatts at a 50 millisecond single pulse. And when in a procedure, you want to verify your glasses. So this laser has 3 different wavelengths and ODs. So make sure, especially with a multi-wave laser, that you're wearing the specific wavelength glasses and OD for each of those wavelengths, because all glasses aren't the same for those 3 wavelengths, as well as the optical density. So maintenance, again, things to do before starting a case for the Treon. Check the slit lamp and console for damage, any cracks. The slit lamp, make sure that's moving properly. The lenses are clean. Clean the device using approved cleaners to avoid damage. Again, on the LIO and slit lamp lenses, you're going to use lens cleaner or methanol. Clean lenses on the LIO, use an approved lens cleaner. Yeah, if dirty, clean slit lamp mirror with methanol and lens paper. Check for breaks in the laser fiber. So the fiber is normally on the LIO, whereas the slit lamp, it's inside the slit lamp. It's not necessarily a fiber. Check for breaks or tears on the power cord, as well as check for damage to foot switches and foot switch cables. So again, making sure they're attached properly, there's no cracks or slits in it or cuts, as well as making sure the shroud is over the foot switch so it doesn't get pressed accidentally. So troubleshooting, this is where you get into the aiming beam and treatment beam, making sure they're aligned properly. If not, it has to go for calibration. So the aiming beam and the treatment beam must be aligned. So if the aiming beam and the treatment beam are not aligned, the treatment beam could hit potentially outside of the aiming beam and where you want to treat it. So some lasers require specific calibration to achieve the alignment. So the easiest way to check for alignment, place burn paper in front of slit lamp or LIO. So what I normally do is stick a piece of paper on the slit lamp headrest, and what we do is place an X on the paper. So align the aiming beam on the X. Right in the middle of the X, I'll push, make sure the aiming beam, the red dot, is in between the cross of the X. Fire laser. What you want to do is verify that the treatment beam is burned where the X is. So in the middle of the X, where you had your aiming beam, you want your burn to be in the middle of that as well. If that's off a bit, it needs to go for calibration. If not, then you're ready to use for the case or the operation. So it's kind of just a quick check on how to make sure everything's aligned, not necessarily an energy check. Energy check's normally done once a year, once every 6 months, depending on the manufacturer. Sometimes we'll do it too if there's issues with the laser that come about. But this is kind of a simple check that anybody can do really to make sure the laser's in alignment and it's not going to cause any issues of where the laser's going to treat. Slit lamp and LIO bulbs. So troubleshooting for these bulbs, if the slit lamp or LIO has no illumination, check the bulb. So bulb may need to be replaced if the filament is broken, and most of the times on the slit lamp and sometimes the LIO, the replacement bulb is keyed into position. So it'll have a little notch in it where it shows where it fits into the slit lamp. So I do have some pictures. On the left here is a slit lamp bulb that we use on our hog straight slit lamps. And right here you can see kind of where it's keyed. On the left here, where it goes in, and the filament, here's where the filament, so you can see where it's attached. Here's one for an LIO that we use on our Heine indirects. You can see as well the filaments attached there, so you know it's a good bulb. You can also do a resistance check too if you wanted to get your voltmeter out and do a check. Just if you can't see the filament, you can do a quick check with that for the resistance. So safety tips, we're going to go over things before starting a case. Check safety filters on microscope specific to wavelength and OD. So if you're using a microscope for a case, and for example, for the constellation where you're doing procedure under the microscope, we do have filters, and I'll show you a picture of that soon, that go on the microscope. They're specific to wavelength and OD, so it protects anybody looking into the microscope. Instead of having to wear glasses, they can look into the microscope and will be protected. Check your eyewear specific to wavelength and OD. Sometimes your patient might need eyewear depending on the procedure, and make sure your eyewear that's specific to wavelength and OD again is on the door. Make sure your danger signs are on the door. Also make sure the fire extinguisher is in the room. Make sure the windows are covered with proper filter coverings. Again, they're specific to wavelength and OD. You can get filters, you can get curtains, you can get blinds. Depends on what your facility would like to have or what's best needed. If needed, saline for any fires on the patient or in the room. Laser mask if there's plume generated, and or smoke evacuator, again, if any plumes generated. You also want to check your fibers just to see if there's any cuts or nicks in it, and check the beam alignment. So the beam alignment was the one with the X. Make sure that your aiming beam and your treatment beam are aligned. So here's some pictures of examples of safety tips. So here at the top left is a pair of safety glasses. Again, make sure that the wavelength and OD are specific to what laser you're using. Down at the bottom of that, is your sign. Again, make sure all your information is on the sign. So your wavelength, maximum output, what class laser. On the top here is your safety button. Don't be afraid to use that. If there's any fire or any emergency, it completely shuts down the laser. At the bottom here is what I was talking about for the microscope safety lens. This one's by Luminous. It's for a Zeiss microscope. Again, 532. It has an OD of 6+. So this goes in the microscope and protects anybody looking down the microscope. So the doctor, for instance, to be protected without having to wear glasses while looking through it. On the right of that is a window covering. So this would be specific to wavelength and OD as well, optical density. This one here is kind of a snap-on version for the window inside the door. And on the right of that is a fire extinguisher. So these ones here, we've gotten questions before on what kind of fire extinguisher to use. So this one is a pure water mist. So it has no elements in it that could cause electrical issues if water hits anything. It's also safe for the patients because it's pure water, so it won't affect the patient. There's no, like I said, elements, salt, anything like that in it. So it's pure water. Also, if you have any questions, this is the end of the webinar. Feel free to email me anytime if you have any questions or concerns or things you might want to change about your policies or procedures at your facility. Feel free, like I said, to give me an email. My email's there, as well as any questions you might have or any concerns. Again, feel free to email me at chevon.mcdougall@nshealth.ca.